Hello, friends. Welcome to today's session of chemistry. As you all know, we have started with seventh lesson of your syllabus, that is elements of group 16, 17, and 18. We call them P block elements. In the previous session, we started studying about oxygen and the compounds of oxygen. In that session, we learned about the methods of preparation of oxygen, the physical properties of oxygen, the chemical properties of oxygen, as well as the uses of oxygen. We also learn about simple oxides and the types of oxides along with their examples. Now, in today's session, we are going to learn about the compounds of oxygen. Only one compound is there which is included in your syllabus, and that is ozone. Also, we will learn about compounds of sulfur. So let us start with ozone. As you all know, ozone with molecular formula O3, it is an allotrope of oxygen. So in nature, it is present in the upper atmospheric layer where these two reactions are continuously or simultaneously are going on. Where molecular oxygen by the ultraviolet light coming from sun gets converted into atomic oxygen. This atomic oxygen, being unstable, is very reactive. It immediately reacts with molecular oxygen and converts it into ozone. Thus, these two reactions are continuously going on, and ozone is formed in the upper atmospheric layer. This layer of ozone, which is present in the upper atmosphere, protects Earth's surface from the harmful ultraviolet radiations coming directly on Earth, and hence it is called as ozone umbrella. Now, let us start with methods of preparation of ozone. Ozone can be prepared in the laboratory by using an apparatus called ozonizer, where molecular oxygen is converted into ozone, where silent electric discharge is passed through pure and dry oxygen in ozonizer. And this conversion of oxygen into ozone is an endothermic process. So, electric discharge will provide that energy. And the ozone is formed is called ozonized oxygen. So, this is the method used to prepare ozone in a laboratory. Now, we will see the physical properties of ozone. Now, pure ozone in gaseous state is pale blue color. In liquid state, it is dark blue color, and in solid state, it is violet black in color. Ozone has a characteristic smell, but if it is inhaled in a concentration above 100 ppm, that is parts per million, it causes nausea and headache. It is diamagnetic in nature. We learn about oxygen. It is paramagnetic in nature as it contains unpaired electrons in the last shell. It gets attracted in magnetic field. What is diamagnetic means? That means all the last shell electrons or all the last orbitals which are present in the last shell are fulfilled. There are no unpaired electrons. Hence, these elements they are not attracted in magnetic field and is called a diamagnetism. That means ozone shows a diamagnetism. Now, chemical properties of ozone. Ozone shows various properties such as oxidizing property, reducing property, as well as bleaching property. We will learn one by one. First one we are going to learn about is oxidizing property. That means ozone, it is a powerful oxidizing agent. It brings about oxidation but because it easily gets separated, decomposes to liberate nascent oxygen, and this nascent oxygen brings about oxidation. Hence, ozone is a powerful oxidizing agent. It oxidizes various compounds. We'll see one by one. First is it converts lead sulfide to lead sulfate. as oxygen is added. That means PBS on reaction with ozone gives lead sulfate along with the liberation of oxygen. So this is oxidation. Second example, iodide ions to iodine. The reaction is like this: potassium iodide, where iodide ions are present, are converted into molecular iodine. This again a oxidation reaction. So potassium iodide on treatment with ozone in presence of moisture, it gives you potassium hydroxide, iodine and oxygen. So this is second example of oxidizing property of ozone. One more we'll see. Ozone can oxidize nitrogen oxide to nitrogen dioxide. That means NO on treatment with ozone will give nitrogen dioxide, that is NO2, with the liberation of oxygen. So these are the three examples which prove oxidizing property of ozone. Now second we are going to see is bleaching property. Ozone acts as good bleaching agent. Bleaching, we learn about it. Bleaching means decolorization, to remove color, because it shows oxidizing property. We have seen this reaction. This nascent oxygen decolorizes given matter, that means colored matter. On treatment with this nascent oxygen released by ozone converts it into colorless matter, that is to remove color from raw silk, from various chemicals it is used. So bleaching properties again shown by ozone. Now, next property shown by ozone is a reducing property. Ozone reduces peroxides to oxides. That means hydrogen peroxide on treatment with ozone gets converted to H2, that is water, and oxygen is liberated. In the same way, barium peroxide with ozone gives barium oxide along with oxygen. So this, as the number of oxygen atoms are reduced in products, it is a reduction reaction. So ozone brings about a reduction, showing its reducing property. Next, we are going to see one important aspect of ozone layer, and it is called ozone depletion. What is it? Ozone depletion is a decrease. What is decreasing? The upper atmospheric ozone gets destroyed, and hence that upper ozone layer is getting thinner and thinner day by day, and that is called as ozone depletion. The ozone layer in the upper atmosphere, it is useful for the absorption of harmful UV radiations coming from sun, and thus it is protecting people on earth, and hence it is called ozone umbrella. But as the layer gets destroyed, what will happen? First we will see the reasons for ozone depletion, and then the effects of ozone depletion. Now, reasons for ozone depletion. Depletion of ozone layer in the upper atmosphere, it is caused by number one, nitrogen oxide released from exhaust system of car and supersonic jet aeroplanes. Now, supersonic jet aeroplanes or the vehicles we are using, after combustion of fuel, they release nitrogen oxide. This nitrogen oxide gets reacted with the ozone in the atmosphere and gets converted into NO2 and O2. Thus, ozone is destroyed, and hence it is ozone depletion. So, as nowadays the number of vehicles is increasing day by day, and the uses of these vehicles brings about ozone depletion. Again, next reason why ozone depletion takes place is CFC, or it is called chlorofluorocarbons, which are or freons, which are released in air by refrigerators. So refrigerators we are using, they release freons in nature, and these escaped freons in nature, they bring about depletion. This depletion of ozone layer is most prominent, it is most present in Antarctic regions or in polar regions. It is more in quantity there in the polar regions. Now, what are the effects of this ozone depletion then? It is the major environmental problem as it increases the amount of UV radiations that reaches Earth's surface. And as the number of UV radiations on Earth, if they increase, what will happen? That will increase the rate of skin cancer, the rate of eye cataract formation, and genetic as well as immune system damage among people. So, this is hazardous. Next, we are going to see the structure of ozone. Ozone is an angular molecule, and the structure of ozone is like this. It is angular molecule with an angle of 117 degrees, and the bond length between two oxygen atoms is 128 picometer. This is the hybrid form of ozone. Actually, it shows these two resonance forms. The double bond between oxygen is not stable, it continuously changes its position, and hence we can draw the hybrid like this, showing dotted line that suggests the double bond can be on either side. So, this is the structure of ozone. Now, uses of ozone. Ozone is used for air purification. It, at crowded places like cinema hall, tunnels, railways, where number of people are more, the released carbon dioxide in air is more, and hence extra oxygen is needed there where ozone is used. Next, in sterilizing drinking water. The drinking water containing germs and bacteria can be killed by using ozone. It shows bleaching property. So for bleaching of starch, wax, delicate fabrics like silk, ivory, etc., ozone can be used. It is used to prepare another chemicals such as potassium permanganate, synthetic camphor. So these are the uses of ozone. So this is all about ozone. We have seen its methods of preparation, chemical properties, physical properties, structure, and uses. Now, let us start with compounds of sulfur. Sulfur, next member or second member of 16th group. Now, we are going to learn about sulfur dioxide and sulfuric acid as compounds of sulfur. The same way as we learn about oxygen and ozone, that is following the same five steps. Firstly, methods of preparation, physical properties, structure, chemical properties, and uses. So let us start with sulfur dioxide. Methods of preparation of sulfur dioxide. It is prepared from sulfur by burning of sulfur in air. Burning means reaction with oxygen. Sulfur on reaction with oxygen or burning with oxygen gives sulfur dioxide. Secondly, from sulfide. Sulfide, that is sodium sulfide, can be converted into sodium sulfate and sulfur dioxide by treatment with sulfuric acid. Thus, Na2SO3 on H2SO4 reaction with H2SO4 gives Na2SO4 sodium sulfate, water, and sulfur dioxide. So this is second method of preparation of sulfur dioxide. Third method is from sulfides, and this is industrial method. Two types of different sulfides can be used as zinc sulfide or iron sulfide called iron pyrites. These two sulfides undergo oxidation in presence of oxygen and get converted into zinc oxide along with sulfur dioxide, or iron sulfide gets converted into ferrous oxide along with the liberation of sulfur dioxide. So this is industrial method of preparation of sulfur dioxide. Now we'll see the physical properties of sulfur dioxide. Sulfur dioxide is a colorless gas with some strong smell called pungent smell. It is poisonous in nature. It is highly soluble in water. When dissolved in water, it gives sulfurous acid H2SO3. It liquefies at room temperature under pressure of 2 atmosphere and has a boiling point. That liquid has a boiling point at about 263 Kelvin. Now we will see the chemical properties of sulfur dioxide. First, reaction with chlorine. Sulfur dioxide reacts with chlorine in presence of charcoal as a catalyst to give sulfuryl chloride, that is SO2Cl2. Secondly, reaction with oxygen. Sulfur dioxide is oxidized by dioxygen in presence of vanadium oxide, that is V2O5, to form sulfur trioxide. SO2 plus O2 gives SO3 in presence of V2O5. Next is reaction with NaOH, that is sodium hydroxide. With sodium hydroxide, sulfur dioxide form sodium sulfide Na2SO3, that is NaOH plus SO2 gives Na2SO3 and H2O. Reaction with sodium sulfide. With sodium sulfide, sulfur dioxide gives NaHSO3, sodium hydrogen sulfide. That means Na2SO3 reacts with sulfur dioxide in presence of water. That means solution of sodium sulfide is treated with sulfur dioxide to give sodium hydrogen sulfide. Now we will see the reducing property of sulfur dioxide. Sulfur dioxide acts as a reducing agent, that means it brings about reduction, but in presence of moisture only. The examples we will see one by one. When moist sulfur dioxide is treated with ferric salts, it's converted into ferrous. That is Fe plus 3 gets converted into Fe plus 2. So Fe plus 3 ions, that means ferrous salts, when treated with sulfur dioxide in presence of moisture, it gets converted into ferrous salts along with H plus ion, that are H2SO4. My sulfur dioxide, it decolorizes acidified potassium permanganate solution. Decolorization is indication of reduction being brought about by my sulfur dioxide. KMNO4, as you know, is dark pink colored solution. When it is treated with moist sulfur dioxide, it gets converted into potassium sulfate, manganese sulfate, and sulfuric acid. Thus, as it is disappears, its color also disappears. And the reaction, we can say it is a reduction reaction. Again, moist sulfur dioxide reduces halogens to halogen acids. What does it mean? Suppose iodine, that means halogen, it is treated with moist sulfur dioxide. It gets converted into HI, that is hydroiodic acid, along with H2SO. Thus, moist sulfur dioxide reduces as the hydrogen is added in the compound. It is called a reduction reaction. So, moist sulfuric acid is a good reducing agent. These are the examples of its reducing property. Now we will see the structure of sulfur dioxide. The structure of sulfur dioxide is like this. It is again an angular molecule with an bond angle of 119.5 degrees. The SO double bond, again it is not stable. It can shift from here to there. And out of these two bonds, one bond is direct sigma bond, but the next bond, pi bond, it is because of p orbital of oxygen and d orbital of sulfur. They overlap by known as d pi p pi overlapping, and they form a double bond. These are the two canonical forms or resonance forms of sulfur dioxide. Now we'll see the uses of sulfur dioxide. Sulfur dioxide has various applications. It can be used in refining of petroleum and sugar. Refining means purification. In bleaching of wool and silk, as an anti-chlor disinfectant. Anti-chlor, that means against chlorine. Chlorine is used for disinfection, but it has some side effect. To reduce those Side effects, it is used as an anti-chlor reagent. It is used as a preservative. It is used to prepare another chemicals like sulfuric acid, NHSO3, etc. Liquid sulfur dioxide is used as a solvent to dissolve number of organic and inorganic chemicals. So these are the uses of sulfur dioxide. Now, the assignment for today's session. You have to write the reasons and effects of ozone depletion. Write down the uses of ozone and sulfur dioxide. Draw the structures of ozone and sulfur dioxide and give the reducing property of sulfur dioxide by using various examples. So, this is all about assignment. Thank you.